Alright, this will be a quick one to wrap us up. All we got to do in this video is 4b, which gives us p of x equals x squared minus 4x plus 1 over 2x minus 3. So, just to get us started, I'll write out my coordinate plane. And we'll go through those steps again. First, we'll be find the domain. In order to do that, I need to set my denominator equal to 0 and see what the zeros of that denominator are. Those are going to be the numbers that are not a part of my domain. And you can see when you add 3 to both sides and divide by 2, you get x equals 3 over 2 or 1.5 for graphing purposes. It might help us out a little bit. So my domain is going to be all real numbers except 1.5. Which also makes me think there's going to be a vertical asymptote at x equals 1.5. Horizontal asymptote is none, right? Once again, because the degree of the numerator is greater than the denominator, or greater than the degree of the denominator, and then slant asymptote is going to have y equals mx plus b form of something that, as I can find by the division here, right? So I get x squared minus 4x plus 1 divided by 2x plus 3. Let's actually do that using synthetic division just to give us a little refresher. A couple of things need to happen here. Remember, the number that goes in the box is going to be the number that makes the denominator equal to 0. So that's going to be 3 over 2 or 1.5. And then also, since this number here is not 1, I have to divide the numerator out again. So instead of being 1, negative 4, and 1, I'm actually going to get 1 half, negative 2, and 1 half. So I can bring down the 1 half, can multiply these two together, which is just the same as multiplying numerators across and multiplying denominators across. When I do that, I end up with basically negative 8 over 4 plus 3 over 4, which is going to give me negative 5 over 4. And then I can multiply here again to get something like negative 15 over 4. No, I'm sorry, over 8. And so 1 half would be like 4 over 8 minus 15 over 8 will give me minus 11 over 8. If you recall, the remainder doesn't matter when we're talking about slant asymptotes. It only matters that it's not equal to 0. So this could be rewritten as 1 half x minus 5 over 4. And I'm going to write it a little unconventionally, but just to help me graph it, I'm actually going to write it 1 half x minus 1.25. That's just going to help me graph this y-intercept. If you plug in your calculator 5 over 4, that's what you're going to get. And so, if I plot my vertical asymptote at 1.5, and my slant asymptote, I'd go down 1.25, and then I would go up 1 and to the right 2, so I'd be about here and there. And then if I go up another 1, I'd be to about 0.75 up here to the right. See if I can get that, and that can give me my slant asymptote. Intercepts here, again, not terribly fun, but if we want to go ahead and find my x-intercepts, let's go ahead and plug it in the quadratic formula. Just, again, only dealing with the numerator, just to see whether or not we're going to be in good shape. I end up with x equals 4 plus or minus square root of b squared, which is 16, minus 4 times a times c, which is just 1, all over 2. That gives you 4 plus or minus the square root of 12, right? All over 2. And there you should end up with looking around again, I'm going to trust the book here. This is telling me 0.27 and .75, and I actually think it's going to be good. 3.75 is going to put me somewhere about out here, and 0.27 is going to put me a little bit closer in here. Okay, and then if we wanted to plug in some points again, we could. Put your final graph after you plug in points. Should look something like this. Pretty difficult stuff, but again, plug in as many points or as few points as you need and use the information at your disposal to be able to gather all this information, plot it, and then just go from there. Okay, again, y'all are probably going to need to plug in a couple more points just to get a general feel for this, but remember, asymptotes have to be approaching the asymptote as we get closer to it, but never are actually going to touch it. And understand how everything else fits around in the different types of graphs we've seen and try to piece it all together. From here, okay, and your sub should have this assignment, but you're going to work on page 138, numbers 9 through 18. Those all only have vertical asymptotes and horizontal asymptotes. I didn't see any that should have a slant asymptote, but look for them anyway. And go back through that process. Remember, vertical asymptotes are going to happen in the zeros of the denominator. Horizontal asymptotes, we have those rules, right, that compare the degree of the numerator to the degree of the denominator. If the degree of the numerator is less than the degree of the denominator, there's going to be a horizontal asymptote of y equals 0. If the degree of the numerator is equal to the degree of the denominator, there will be a horizontal asymptote at y equals the ratio of the leading coefficients. And finally, if the degree of the numerator is greater than the degree of the denominator, there will be no horizontal asymptote. If the degree of the numerator is exactly 1 greater than the degree of the denominator, like it was here, we can look for a slant asymptote by performing the division and, again, ignoring the remainder. Sounds good. Good luck. Make sure that you write down any questions that you have for me, and I can answer for those on y'all for y'all on Monday. If you do happen to need me urgently and want to figure some of this stuff out, I should have my phone on me. Send me an email, and I'll get back to you as quickly as I possibly can.